So good afternoon, welcome, thank you for coming. The first thing I did at the first presentation I ever gave was apologize for the slide, or for the title. And so I'm also going to do that today. Somewhere between our desks in Ann Arbor and I'm not sure where the desks were, but a word got dropped. So the talk is actually instructors' concerns about teaching inquiry-based learning mathematics courses. And then we've since added a preliminary report, but it sounds a little less ominous about, it's not our concerns, it's your concerns. So like Stan said, my name is Tim Whittemore. I'm here presenting work I've done with Vilma Mesa and a third colleague, Mary Sully, who cannot be with us today. And as the title suggests, we're going to talk about instructors' concerns. So a brief overview. I'm just going to describe the study, how it's worked, what our research questions are, a little bit about the method that we've been using, some preliminary findings. Preliminary is a nice word because it means it's ongoing and we don't have all the answers yet. And then we're going to end with some how can this help, where do we go from here type questions. So we're interested in how people learn to teach. And it's a big question. In education, that question has mainly been focused at the K-12 level because that's where students are. So we know, or we have theories about how K-12 instructors learn to teach. And there aren't necessarily the comparable theories in university settings for post-secondary instructors. So it's fairly limited about how this development happens. The two theories that we've been drawing from, and this one by Nardi and her colleagues, they looked at the stages that that university tutors take on as they're teaching. And then a second one is Nyquist and Sprague looked at the trajectory that teacher assistants, TAs, go through as they begin to teach. Nardi found that university tutors were sometimes naive and dismissive, sometimes intuitive and questioning, sometimes reflective and analytic, sometimes took on confident and articulate teachings. These aren't necessarily a trajectory as people move through those. There's different stages that people can embody as they're teaching. A trajectory that Nyquist and Sprague that proposed was that based on their observations, teaching assistants initially are worried about themselves. Am I going to make it through the class? Do the students like me? Am I going to survive? Those concerns move into concerns about class management. Is everyone in their chairs? Are people asking questions? Are people, not shouting out? And finally, possibly, those concerns move into concerns about student learning. Do they get it? Are they understanding things? And these seem like reasonable theories that might match how university instructors go about learning to teach and developing expertise. Again, however, this one was from working with university tutors. This one was university teaching assistants. So instructors are kind of a new phase. So that's why we're interested in teacher learning side of this. The next part is why are we interested in IBL instructors? Well, in K-12 settings, reform can be handed down at some level at the district. They say, we're adopting a new curriculum. Teachers adopt the new curriculum. That doesn't necessarily happen in university settings. And so it's looking at reform, tracking this reform is a much more individual basis, and IBL instructors are reforming the way you teach. Also, we find you guys fairly intentional in what you're doing and pretty insightful about what you're doing, so that was a nice little reason. IBL instructors face dilemmas that lecture-based instructors don't face. Right? They have to worry about how much do you tell students. They have classroom discussions. Right? If you go into a big lecture hall, there's less of a need to be able to facilitate a discussion. And lastly, you need to kind of assess student learning in this ongoing way. You talked about the ready feedback that needs to be adopted, and you can't simply say, today I'm going to teach this, and I'm going to lecture for my 45 minutes, and then I'm going to be done for the day. So IBL instructors face these dilemmas, and we wanted to see how they deal with that. This study that the work I'm presenting today is a larger part, or a small part of a larger study. Our research questions are here. The one I'm going to talk about is the top. What are the common challenges and concerns faculty report experiencing as they teach with IBL methods? So, how did we go about doing that? Last year, I was here and I sent out a request. I recruited. So we ended up recruiting instructors, asking them if they wanted to participate in the study. We got a sample of 34 instructors. We asked participants to classify themselves as either beginning, novice, advanced, or expert with respect to their familiarity with IBL methods and how they saw themselves as a practitioner. So this 24-13 split is the participant self-categorization. We also asked what courses they were teaching, and we found a widespread among these participants. Lower division courses, there were 14 instructors teaching lower division courses. This is calculus, linear algebra. Upper division, 13 upper division courses. Those would be number theory, abstract algebra, kind of the upper division courses. The ones that start with 3 or 4, generally. We separated out those instructors teaching future teachers. So our past work has shown that these classes are different than IBL number theory, for instance. So we've set them out, but we also were happy to have a good sample of that. And some of the more information about the wide range that these instructors were coming from. The instrument that we used was online logs. Every 2 weeks, I would send out a log, have some questions. In your handy-dandy handout is kind of a sample of the questions that were in that log, that first page. We asked questions about the most recent class you taught and just kind of a reflection on the previous 2 weeks. We asked questions about class time, the math content that was covered, what types of concerns you had, and what you remembered about the class. Over the past year, starting in September and up through about 2 weeks ago, actually, we've sent out 16 waves of these logs. We had 241 logs come back. If you do math real quick, you will see that 34 instructors times 16 logs is not 241. So some people returned every log, almost every log. Some people only returned 1 log. It ranged based on schedules or life gets in the way and life gets busy. But this was the data set we were working with. We ended up with 241 logs at the end. With this robust set of data, we went through the responses, we parsed them, looking for themes in the comments. We ended up with more than 2,500 comments, which is a big number for the kind of qualitative work we were doing, so that's been a fun experiment. We used ongoing and open coding, looking for the common themes, and as the logs were coming in 2 weeks at a time, this was ongoing, right? So we would code one set and then code the next set and redefine how those logs were, or how those codes were defined. It's still evolving. That's the preliminary finding part. Looking across those logs and across the coded themes, they fell into some nice groups. So instructors, I'm not going to read these all. You can read them. And these are actually also loaded in somewhere in that handy-dandy handout. These are the concerns, or these are the themes that instructors wrote about, not necessarily concerns. These ones, assessments down to student understanding, and up in that corner with student motivation, teacher encouragement, and tuning to students' needs, those were comments that we looked at as kind of concerns. We also asked instructors to write about their mathematics, so they wrote about their mathematics. Sometimes nothing happened, sometimes they were just reporting events, reflecting on methods, and they also offered solutions and talked about how they went about addressing the difficulties they were facing. However, our question, if you remember, was what are the common concerns? So we just focused on kind of the top bit in the left column. So we have a big pool. We code them. We collect them. We count them. And we find this distribution of concerns. So These are organized by the number of instructors that reported that concern at some point in the semester. So that's the first column. Second column is the number of comments that were coded as that particular type of concern. And the third is the percentage of logs, so kind of how frequently were they appearing. The first thing to look at is student difficulties. Instructors' concerns about student difficulties are huge, right? Our sample was 34 instructors, and 34 instructors had concerns about student difficulties. They showed up at 82% of the logs, so they didn't all happen at once, right? They're happening throughout the semester. And there are a lot of them. So that's the first thing that jumps out. The next thing that jumps out is really that, well, actually, these top four are very well represented. Right? This is more than 3/4 of the instructors had concerns about student difficulty, class pace, motivation, and understanding of their students. Then we get this next little chunk that's, well, more than a half, less than 3/4. Assessment, tuning to students' needs, the use of resources, and how teachers can encourage their students. And then these last four were common, but less than half of the instructors had concerns about lecturing, balancing their responsibilities, managing the class, or focusing the discussions. So that 349 comments, those 349 comments on student difficulties, that's a lot. So we wanted to get back and really tease that apart. When we went back in and subcoded those comments, we found that those broke down into generic comments. There were a couple proofs they got stumped on. Could be in any class. Comments that were about students' difficulties with mathematical procedures, with kind of IBL methods, so presentations, writing out proofs in a formal way. And then lastly, students' difficulties with just knowing mathematical knowledge. This quote is lovely, and I love it. Some students are still struggling with the exact meaning of the definition of continuity at a point. They're thus having trouble formulating an argument that establishes continuity or uses continuity to establish some other condition. That's a nugget of mathematical knowledge that has been identified as students lacking this little bit, and then so once you can identify it, then you can address it. And so they do address them, right? We ask about solutions to these concerns. We asked, how do you address these difficulties? And these are the ways that instructors were addressing the difficulties or the concerns about student difficulties. So a subset of the solutions that instructors found. There aren't numbers for these. These are the 5 most popular, might not be the right word, but most used strategies. It was very difficult to kind of link strategies to solutions, but we're working on that. So instructors have discussions with their students. They present examples or have examples kind of in their back pocket that they're ready to pull out, maybe counter examples if students are having difficulty. They revise the problem sequence. They insert a few easier problems. They add some supplementary material. IBL instructors give lectures, just like little mini lectures. It's okay. It moves class along, right? Class pace was a concern, and a mini lecture is a quick way to get through a little bit. And then they also clarified the expectations. This was particularly tied to the concerns about the students' difficulties with the IBL method. Right? Like, we've heard this is a new thing that students are doing. They've had 20 years of instructors giving them the material, and now we're asking them to do their own work. So those are those sorts of things. So in conclusion, my time is running out quick. These concerns, they're common across the board. Right? We ran the numbers. We did the statistical. We're looking for differences. There aren't differences between the beginning and advanced instructors. There aren't differences between the lower division, upper division, future teachers, which is a little surprising, but they're common. All IBL instructors worry about this, or many. Another finding was that the data do not fit the models that we initially started out with, right? Those 4 stages or the trajectory. We didn't find, or we found very few kind of naive and dismissive comments. We found very few instructors who reported concerns about themselves. Everything was, the numbers had, very student-centered. So those models don't really work. And if the models are getting you to concerns about student learning, IBL instructors are there. They're concerned about understanding and students' difficulties and students' motivation. They're kind of at that far end. So, on the other hand, this might not be so surprising, right? You have concerns about pacing, coverage, assessment, lecturing. These are the things that's kind of the nature of IBL instruction, to be a little slower. You know, it's a little harder to run assessment, and you know, sometimes lecturing is not there. As far as explanations go, the pool of instructors we were working with were fairly experienced. And experienced instructors, not necessarily experienced with IBL. And the models we were initially drawing from were based on university tutors and TAs, teaching assistants that don't have years and years of experience to draw on. So, how can this help? Well, it's actually just more questions. So, we found that IBL instructors are attending to the students, right? And their difficulties, there's the student motivation, student understanding of the material, that's a worry. With that in mind, I guess a question for the community is what types of workshops and activities can be designed to help instructors address these concerns? The other part that we'd like to offer is that the solutions that instructors found, the ways they went about addressing those student difficulties, kind of felt like they were the instructors, or when we read the comments, it sounded like the instructors were saying, let me show you how to do it. Right? Like, let me give you a mini lecture real quick. Let me show you an example. And so what are some other strategies that might be used to address these concerns? Because they are out there. I'd like to give special thanks to EAF, also to the Europe, which is the Undergraduate Research Opportunity Program. Mary Sully came out of there. And also to the participating IBL instructors. It's been wonderful to work with them over the course of this past year. We have 2 minutes of questions, and then Stan yanks me off. Actually, Stan is yanking me off as you're asking the questions.